The Proterozoic Eon is the third division of Earth's geological history, following the Archean Eon and preceding the Phanerozoic Eon. It extends from approximately 2.5 billion years ago to about 541 million years ago. The Proterozoic Eon is a crucial period in Earth's history, categorized by significant geological, biological, and environmental changes that set the stages for development of complex life forms. During the Proterozoic Eon, Earth's continents continued to grow and stabilize, leading to the formation of larger landmasses and the assembly of supercontinents such as Rodinia. For more about continents and plate tectonics, visit our video on plate tectonics and supercontinents. These continental collisions and rifting events shaped Earth's geological landscape and influenced global climatic patterns. One of the most significant events of Proterozoic Eon was the Great Oxygenation Event, or GOE, which occurred around 2.4 billion years ago. This event marked a dramatic increase in atmospheric oxygen levels, likely resulting from the photosynthetic activity of cyanobacteria and other early photosynthetic organisms. The rise of oxygen had profound implications on the evolution and the chemistry of Earth's ocean and atmosphere. The Proterozoic Eon witnessed the emergence and diversification of eukaryotic life forms, including complex multicellular organisms such as algae, protozoa, and early metazoans, aka animals. Fossil evidences from this period provide insight into evolutionary transitions from being single-celled to multicellular forms, as well as development of diverse ecological communities. The Proterozoic Eon was characterized by multiple episodes of glaciation, during which large portions of Earth's surface were covered by ice. These snowball Earth events occurred intermittently throughout the Proterozoic Eon, leading to the formation of extensive glacial deposits and influencing global climate dynamics. The Proterozoic Eon saw the deposition of significant mineral resources, including iron, copper, zinc, and uranium ores. These mineral deposits formed throughout a variety of geological processes, including sedimentation, hydrothermal activity, metamorphism, and continue to be of economic importance today. The Paleoproterozoic era extends from approximately 2.5 billion years ago to about 1.6 billion years ago. It is characterized by significant geological and biological developments, including the stabilization and growth of continental landmasses, the rise of atmospheric oxygen level, and the emergence of early multicellular life forms. Important events within the Paleoproterozoic era extends the Great Oxygen events around 2.4 billion years ago, which led to significant increase in atmospheric oxygen levels, and the formation of supercontinent Columbia, which is also called as Nuna. The Neoproterozoic era spans from approximately 1.6 billion years ago to about 541 million years ago. It is characterized by profound geological and biological changes, including the assembly and breakup of supercontinents, dramatic fluctuations in global climate, and the emergence of complex multicellular organisms. The Neoproterozoic era is further divided into several periods and epochs, including Tonian, Cryogenian, and Ediacaran periods. The Tonian period, from about 1.1 billion years ago to 720 million years ago, represent a time of relative stability and gradual environmental changes. The Cryogenian period, from about 720 million years ago to 635 million years ago, is characterized by extensive glaciations and snowball Earth events, during which much of the planet's surface was covered in ice. Towards the end of Proterozoic Eon, around 635 to 541 million years ago, the Ediacaran period saw the emergence of Ediacaran biota, a diverse assemblage of early complex organisms. These organisms, which included enigmatic forms such as Dickinsonia and Kimbrella, represent some of the earliest evidence of macroscopic life on Earth. Spanning approximately 900 million years, the Paleoproterozoic era saw the formation of supercontinent Columbia, During this era, Earth's atmosphere was primarily composed of carbon dioxide and methane, with little to no free oxygen. Periods of fluctuating oxygen levels formed the banded iron formation or BIFs. The Paleoproterozoic also saw the emergence and diversification of early life forms including microbial mat, stromatolites, and possibly the earliest eukaryotic organisms. The Mesoproterozoic era is characterized by significant geological and tectonic events, including the breakup of supercontinent Columbia and assembly of supercontinent Rodinia. Several large-scale orogenies occurred during this period, leading to the formation of mountain ranges and continental collisions. The emergence of more complex eukaryotic organisms, including algae and early multicellular organisms, occurred during this era. Glaciation events such as Huronian glaciation occurred during the Mesoproterozoic, leading to the widespread ice coverage and global cooling trend. During Neoproterozoic era, Earth experienced significant environmental changes, including the breakup of supercontinent Rodinia. The Neoproterozoic is known for several glaciation events, which are collectively known as Snowball Earth events. The emergence of first animals, including the Ediacaran biota, occurred during the late Neoproterozoic, marking the transition to Phanerozoic Eon. The Neoproterozoic ended with the onset of Cambrian period and the Cambrian explosion, a rapid diversification of multicellular life forms.